So in this program, in this video, we're going to talk about programming multiple jobs into one master job. Typically, good practice is if we're programming, we should have um, non-motion commands not mixed in with motion commands. So for instance, so if I hit edit, everything here, the U frame, tool frame, those are my reception, but these are all motion commands. A lot of the times, though, we want to break up jobs so that we have the ability to change things up if we need to by just calling out to those jobs when we want them to be run. So, say I have this complex program where I'm welding around a triangle, square, circle, and a specialized combined part. And just to show you, if I hit menu, I'm going to go to edit, and I'm going to go to part or select part and hit enter. You can see it's a different tool, user frame, same tool, but you can see I have a combination of joint, linear, and circle commands in there. And if I zoom in, you can see I'm pretty doggone close. Don't worry about the lines there because it's going to arc. And if I want, I could probably move that out a little bit. Yeah, like that. And you can kind of edit that on the fly. So this is my main job, my main welding part type setup. But if I wanted to change the order of these things, or if I have a cycle where it's like the part circle square rather than part square circle, if I record all in one big job, that's going to take a lot of editing. But what I can do is take a master job and call out to these things. So first things first. We'll talk about setting a position register. So I'm just going to move this out, like out here into space somewhere. Okay, just kind of as a safe position or a home position. I'm just moving it there somewhere around there. So say that's a safe position away from each part. Okay. And if I want to record a position register, let me find my teach pendant. If I want to record a position register, I have to go into data. Here are data registers. Data registers are just going to be ways of saving numbers. So if you've done any PLC program, think of dints or integers, or a word or double word, for instance. But they're just numbers that are being like whole numbers that are stored. They can be negative or positive. But if I hit type, you'll see position registers. This will allow me to save positions. And I'm going to go into position register 11, and I can give it a name. I can give it a name if I hit enter here, and go down to keyboard. I can call this safe position, so it's out of the way. Usually you want a safe position. Hit enter, and now that's my position. If you see a star over here, that means nothing's been recorded. I'm going to record this position here. Shift record, and now that's been recorded. If I want to see the position, I hit enter or position. And you can see that it's been recorded. And if you see X, Y, Z, W, P, R, that's going to be in rectangular coordinates. So it's going to be user and tool frame specific. So if I want something that's probably a little more universal, I might want to change the configuration, not the config, the representation to joint. Because that will give me the, because you can see that position data was based upon user frame tool and active tool 1. So if I try to run this position, if another two, it won't go there because it was recorded in another user frame. But in joint, now it's all based upon degrees of motion, and that's going to be a little more universal. So now it's been recorded by the joint position of the robot versus relative to coordinates in space. Okay, so there we go. It's now, and you can see now that's in joint position. You can do it either way. I'm just showing you that that's an option. And if I want it, so I'm going to now go in and create a job, and I'm going to create a job called keyboard bike red. Maybe we're welding a bike frame or something. So hit enter, and I hit edit. And again, I don't know why this keeps crashing on me a little bit, but hit edit. And if I wanted to move this to the safe position every single time, I could record my own, if I want to be specific, I I could just actually go in here. And so before I do anything, let me create another job. Create. And let's just call this safe. Hit enter. Hit edit. And now I can just go in instructions, not instructions, F1, but not instruction. Point, make sure it's a joint, and I can do continuous. But instead of making this position 1, let me choose position register 11. That way, I can always call out to that position if I need to in a job or whatever, but that would be the only thing that this job runs is going to that safe position. Okay? So now I can go back in, and I'm going to go back to my bike job. So bike red. Hit enter. So the first thing, so what we're going to do if we have these jobs, we call out to those jobs. Okay? So instruction, call, and I can go in and call safe. Okay? That'd be the first job I call. Make sure it goes there. I can then call my other job. So I'm going to go call circle, and I'm just for a second, let's call part. Maybe that's the only thing I want for the red bike part, for instance. Call, part. Okay, and there I go. There's my 3 positions. I hit shift forward. Everything is there. And now it goes to my circle job, is going around the circle. Does the whole circle. Moves back to a safe position. Now it goes over my part, and it will do my part. And if I wanted to change the job, all I got to do is change when I call things. Because what the call does is call goes out, runs the job, goes back to the place that you called it from. And if I wanted to, I could put another call job inside this job to do something else. And I could nest call jobs. So now if I go back and do it again, hit forward, I'm back to that position register and back over to circle and went right through it and went back at it again. So that's how. And that would just call it once, do it once. Okay, that's it. Let's say, for instance, though, we want to keep track of how many times we ran this job. So let me go to select, hit function abort all, because once you get in a job, it's kind of hard to get out. So function abort all, and then go back to your job. I'm going to insert some lines in between here. So I'm going to go to edit command, insert, and I'm going to insert a couple lines. Okay. So say we want to track how many bikes we're going to make. That's where we would use those registers. If I go in, and I can go into register, what I can do is say register 25. Make that a constant of 0. What that does is reset my register before I run the job. Okay? And then what I can do is put in something what we call a jump label. If you've ever done PLC programming, they may say don't use jump labels because you can create a loop. Well, in robotics, we use jump labels all the time. And now I have a jump label. And now I can just put in what we call an instruction. An adder instruction. And this is the basic syntax for adding. Basically, what all this does is say, take whatever's on the right side and make the register equal to what's on the right side. So in this case, it's going to say, take whatever's currently in R25, which at this point will be 0, add 1 to it, and then set that equal to that. So far, so good. And so now the last thing is that I can put a jump label in and jump back to label 1, and now it's going to keep running this job. So if I go in here and hit shift forward, it goes back to my home position. Now it's going to run the circle job. And I'm going to speed it up a little bit. So run my part job. And now it's just going to keep running. Back to circle, back to part, does the well, back to circle, back to part. And you can see if I go into data, type, register, if I click this item button, and type in 25, it's going to take me right there. And you can see I have 3 already. Okay? But if I just do function abort all and go back into edit or select and go back into bike red and hit enter, if I go run this again, and I'm going to step through it, forward, forward, and I go back into data, you'll notice that it's back to 0. What I would recommend when you start recording stuff is make sure that you have a way to start the job consistently every single time. Because you don't know if that register is being used by another job. You don't know where you left off, but if you want to restart something, make sure you it's 0. The other thing that we can utilize is so those are registers. We can also turn on and off inputs and outputs. So I'm going to go in and I'm going to go. What we'll do is, if I was in the real world, this would be a lot easier to show because I can actually make things do stuff. I'm going to go back to edit command. I'm going to hit insert and I'm going to do a couple lines here. Okay. And I'm going to do one line here, one, and one line here. Okay. But I'm going to go in and I can go to these IOs and I can say, hey, because the job is starting, turn off. So if I can have a digital output, I'm going to do 10 and see, and I can, and I'm going to make sure that's off. So say digital output 0, digital output 10. And if you want to edit this, all that can be done through the IO menu. Way down here at the bottom of the Teach Pendant, there's an IO button. And if you type and hit the in out or type digital, and make sure you go between in, out. Which one did I say? I said edit. It was digital output 10. Go back to IO. Down at digital output 10, I could say running run. I can go in here and hit go into detail, and I can put a comment. Hit enter, and I could say this is just say, I don't know, red bike. I don't know, red bike running. So if this was tied to a PLC or something or an HMI, you could say red bike running. Okay, hit enter. Whoops, options, keyboard. Yeah, red bike run. Okay. And now previously you can see that's on the description. Okay. If I go into edit, this is going to give me the current status. This is going to turn out. If you want to hide that in some program, you can go in here and turn off the IO status. If you want to turn off the color under edit command, the color can't get turned off. I kind of like the color. I don't, if you want to do the IO status, you can. But we can do it that, so that way it turns it off. Okay. So that when I run, then when it gets done, I can say turn, let me insert one line. Sorry, insert line in the wrong location. And so now I'm just going to copy this, edit command, copy, select, just copy that one line, paste. We can paste the logic. And now I can just change this to on. And so that when this starts running, I can say, okay, it's clearly on while it's running. And then before it, and then when it gets done, I can turn it off. Copy, paste. Yeah, turn that off. Okay. And let me just go in here and paste because I'm probably going to delete that other thing. Whoops. Command delete. Yes. Okay. So now when the circle's on, just that's there. Okay. Just so we can see a difference. If you hit Shift and Display, you can do a double monitor on your Teach Pendant. And it should come up split. And on this side, I can actually put up my I/O and monitor it in theory. And so now, but the main job always has to be on the left side. So I'm going to hit, so I'm up at the top. I'm going to hit function abort all and make sure I'm not running anything. And now I'm going to hit forward. And you see that output's on and now it's off. On, off, because every time I get to the part job, it's going to turn it on and it turns it off after the job. So this is the way that you can, and if I can even go here and go to data, and you can see it's counting 25. So item 25, enter, and you can see it's ran 4 times. So this is how we can start like doing some engaging the outside world, turning inputs on and off. You know, if you're controlling a gripper, the same thing will hold true, except on I/O, there's multiple different types of I/O. So you can see digital I/O, that's being sent out to the outside world. Robot I/O is the actual I/O on the robot. That's going to usually be a gripper or sensors that are on the, you know, like end of arm tooling. But the command lines are all the same, okay? UOP is how you can control, but we're not going to go that, you know, you can monitor it. We're not going to go that far to things, okay? So, but that's how you can do some commands. Function abort all, back to bike red, enter. But now you might say, okay, I want to modify it. Well, this is where I can go in and add in instruction, call job. And let's just say that the red bike is the same, you know, the red bike is the same, but maybe some features of the red bike have certain other things involved. So I can go into instruction and we can start doing if statements. And I can have it set off of a digital input. So let's just say digital input 1. If that is on, call square. If digital input 1, oh, I have 11. Okay, same thing. Or no different. Oh, I can go here and just do 1. Enter. If 1, call square. Otherwise, it'll jump over it. The other thing I can do is I can do if commands based upon the registers. So if this is less than or equal, if register 25 is less than or equal to 5, then jump label back to 1. Otherwise, skip it. Because what this will do is allow us to say, hey, only run this 5 times. So let me run this job from the beginning and show you how this looks. So there's probably 1. There's 2. But just to stop for a second, I'm going to go in here and go to I/O. And right now, in the real world, I wouldn't have to hit simulate. You know, here I got to go sim, unsim. And then, but here, that's the only way I can show you how this works. Then I can go hit on. And let's see what it does if it goes to the square at any time. Forward. I'm in the circle. Now it's doing the part. Now it's doing the square. Because I called for it, now it's going back doing the circle and doing the part. And I'm going to keep doing this till it gets done. Because if I go into my data, 25, you see it hit 5. And let's see if it stops after this time. So there's my circle. And if we did it right, it should stop right now. If I didn't put the wrong register in, which I have a sneaking suspicion I did. Red bike. Function abort all, select, edit. Less than or equal to 5. Okay, no, it's now, yeah, it's going to stop now. Because the way I had it, it was equal to 5, so it jumped back through. So let me run it. Let me run it from right this position here. And it should skip. See, that's why you got to be careful with how you do things. with the less than or equal to. I did less than or equal to. I should have just did less than. But that's the jump That's the jump label. If I want to run the job again, I can go in here and just run the job again. And it's going to go back to the square because the input's on. Keep running it. And I'm going to go in and see if I can go into I/O. It probably won't let me. If I was actually running, and I'm going to turn this off. And now if I go back to here and keep running it, and by the way, in that square job, you notice that there was some commands in there. Let me turn that back on so you can see. Forward. In square, you can see right here an arc command on and an arc command off. So I can embed these in the job as well. This is a wait command. I'll get to that in another lecture. But basically, under instruction, I can, if I'm doing, I can make it wait for a certain amount of time. But again, this is just to show you what's possible. Some basic looping. I have another thing on this looping and adding that you can look at, but I'm just trying to show you how you call, do some ifs, do jump labels. You can put labels in without things running. Some basic motion commands and how to turn on and outputs and registers. Okay. Again, play around with this. You should have fun, but now I'm done because I've hit my max quota. But this is the good practice. And if I was actually welding, here I would actually go into here and I would make sure that instruction, IO, digital output 1 was off because it was actually the arc. I can make sure that it was off just in case for some reason it was left on by something else. I make sure that it gets called off. And you do that all outside the label. All right? Hope this was helpful. It was just kind of more of a, this is how you build a job, some of the tools you use in the instruction menu. And again, everything, and I'm just basically using these first 6 here. Those are the big ones of programming. All right? Have a good day.